This lesson is called Combining Functions and Composite Functions. Up until this point, we've just been combining functions. Now we're going to composite functions. And so it says, given two functions f and g, the composite functions denoted by this notation right here reads f composed with g is defined by. So if we have f composed of g of x, then that means we have f of g of x. So what we are doing here when I have a composite is I am making a new function, but I am inputting a function inside of another function to give me its composite function. So for example, in example 5, and then I want you guys to try to pause and try to do example 6 on your own. Example 5 says, suppose that f of x equals and g of x equals. Find, we need f composed of g of x. So if I expand that out, that is f of g of x. Now with compositions, we need to start on the inside. So the first thing I'm going to do is look at my inside function. My inside function here is g of x. So now I am going to substitute in my g of x function for where I see g of x. So this is 6 minus 7x. And now function notation, if I have f of whatever's in parentheses here represents my x. So now I'm going to go into my f of x function, and where I see this x here, I am replacing that x with what I have in parentheses. So now that is 5 times 6 minus 7x plus 3. I replace this x with what I had in parentheses. So now simplify this. Distribute this 5, and we get 30 minus 35x, bring down your plus 3, and now combined like terms. 30 and 3 will become 33. So this is minus 35x plus 33. Now let's see if the order matters. Let's do our composition in the opposite order. Now we're going to do g composed with f of x. So if I expand that out, that is g of f of x. Starting inside, we have f of x. So replace this f of x with what f of x equals. So we have g of 5x plus 3. And now I'm going to go to my g of x function, and whatever is in parentheses here, we are replacing this x with. So we have 6 minus 7 times what we have in parentheses, 5x plus 3. Now distribute and solve again. So negative 7 times 5x is negative 35x, and negative 7 times 3 is negative 21. Combine your like terms, and we're going to get negative 35. 6 minus 21 gives me negative 15. You can see these are similar because they both have a negative 35, but this constant is very different. So order matters here. These are not the same thing. Now, again, if you think you're comfortable with trying example 6 on your own, please try example 6 on your own. Hopefully you either had time to pause and try it, or if you're not comfortable, let's work through another problem here. We have a new f of x and a new g of x. And we're going to do these again in both versions. So f composed of g of x is f of g of x. So starting inside, replace g of x with what it equals. G of x is just the square root of x. So we have f of the square root of x. And now I'm going to go into my f of x function, and whatever's in parentheses, I am replacing with this x here. So we have 4 times the square root of x minus 9. Now, I can't do anything with that. All I can do is kind of multiply 4 times the square root of x is 4 square root of x. Okay, if you're feeling comfortable, try part B. If not, here we go. G composed of f of x is g of f of x. So starting inside, we're going to replace f of x with what f of x equals. So this is g of, what does f of x equal? It equals 4x minus 9. So now I'll go into my g of x function and replace that x with what I have in parentheses. So this x is getting replaced with this. So we will have the square root of x, which x equals 4x minus 9. Can't do anything to that. So that is my answer.